Okay, students, welcome to this wonderful teaching again. And in today's class, I'm going to talk about the trapezoidal rule. The trapezoidal rule is trying to solve the integration problem. Integration problem can be solved by the trapezoidal rule. That is called a numerical method. So let us discuss about the problem here first. A rocket is launched from the ground. Its acceleration is registered during the first 80 seconds are given in the table. Find the velocity of the rocket when t equals 80 seconds. So what is the problem about? Okay, so let us have the pictorial diagram of that. Now solution is what we have to find out. Now let us have the description of the problem. This is a rocket. It is launched in the sky, and the tabular form is given like this. At the top of these lines is seconds given, and below that the velocity meter per second is given. The first 0 second, then 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds, 60 seconds, 70 seconds, and 80 seconds. What about the velocity? For the first 0 second, the velocity is 3. Right. Now for the 10th seconds, the velocity is 31.63, and then for 20 seconds the velocity is 34.4, and then for 30 seconds, when it reaches the 30 seconds, the velocity is 35.47. When it reaches 40 seconds, the velocity is given as 37.75. When the second reaches 50, the velocity is 40.83. When the seconds noted, the velocity was 43.75. When it reaches the 70 seconds, the velocity is 46.61, and when 80 seconds noted, the velocity was 40.67. Now what we need is that the total velocities when it reaches t equals 80 seconds. That's what we have to find out. So this problem is like an integration problem. Now look at that. We are going to use here trapezoidal rule. You know what is trapezoidal rule? So given problem can be written as 0 to 80 f of x dx. Now the trapezoidal rule says h divided by 2 inside the bracket, first ordinate plus last ordinate plus 2 times of the sum of the other ordinates. That's what the trapezoidal rule says. So here the y ordinates here is velocities. So the first velocity is 30, second velocity is 31.63, third velocity is 33.4, fourth velocity is 35.47, fifth velocity, seventh velocity, eighth velocity, like that. Okay. Now we are going to apply the trapezoidal rule that says h by 2. Here what is h? The common difference between the x ordinates. So here common difference is 10, am I correct? So that 10 divided by 2, and then a bracket starts the sum of the first velocity and the last velocity. Okay, first velocity and the last velocity. So that's what 30 meter per second plus 40.67 40.67. So that's the first bracket. Okay, plus 2 times the sum of the other velocities. Okay, so now 2 times the sum of the other velocities. What are they? 31.63 plus 33.4, sorry, there's some mistakes there, plus 35.67, then 47, sorry, plus 37.75, then 40.83 plus 43.25 plus 46.61. So if you simplify this, what you are getting is 3037.95 centimeter per second. Okay, so when you simplify all this, what you are getting is 3037.95 centimeter per second. This is what the velocity of the rocket when it reaches 80 seconds. That's what we are getting. So when t is equal to 80, what is the velocity? These are the x values, these are the y values. X values are seconds, y values are velocities. Therefore, when the x equals 80 seconds, what is y? And y is equal to 3037.95 centimeter per second. Okay, so this is the way we can solve any problem, okay, by using what is called trapezoidal rule. So trapezoidal rule is what we have to understand. So with that, I am coming to the end of this particular problem. So let us have a recap. A rocket is launched from the ground and the velocities are noted for different seconds, for 0, 10, 20, 30, 40, 50, 60, 70, 80, and then velocities are noted. We have to find out the velocity when t equals 80 seconds. When the time is 80 seconds, what is the velocity we have to find out. Trapezoidal rule we are using here. Trapezoidal rule is h divided by 2. H is the common difference in x-axis. H divided by 2, and then first velocity plus the last velocity plus 2 times of sum of the other velocities. When we simplify, we are getting this answer. Therefore, integration 0 to 80 f of x dx equals 3037.95 centimeter per second, and this is the velocity when the second is 80 or 80 seconds. When it gets 80 seconds, since it started, then the velocity would be 3037.95. Yes, thank you very much.